to keep that theme going, of course, once you've done half a lifetime in mining and you see safety and opportunities, it only makes sense to take a quantum leap and go into vehicles. Our next person, ladies and gentlemen, Steve Durkin, is the MD for SafeScape. That's exactly what he did. He started with safety. He took his mind, he took his brains, he took his money, and he became a company and a force de majeure that we'll see grow and grow as the vision grows. Ladies and gentlemen, please welcome the Managing Director of SafeScape, Mr. Steve Durkin.
So thanks very much for that. So we don't have the same brand recognition that Hyundai and Nissan have got. So I'll give you a quick intro to SafeScape. We design, manufacture and supply products that are safety products to the mining industry. To date, we've supplied more than 120 mines across 22 countries. When we develop a new product, it has to improve safety and/or health outcomes in the mining operation that it's designed for, whilst at the same time reducing costs. Several of our products are unique inventions and have patents spanning the globe. Typically, our products are made from plastic and benefit significantly from a reduction in exposure to corrosion when compared to alternative options. It might seem like a strange progression from manufacture of plastic safety products to electric vehicle OEM, but at the core, we're delivering the same thing we've been delivering for 10 years, safety and health improvements that reduce waste and inefficiency and drive reduced costs. An underground mine is essentially a network of interconnected tunnels, often tens or hundreds of kilometres of them, which access areas of rock where concentrations of economically important minerals exist. By creating these tunnels to access the rock that contains the minerals, which we call ore, we're then able to extract them by various means. First breaking the rock, then loading it onto trucks and trucking it out through tunnels to the surface, where we can extract the minerals that go into making our EV batteries, motors, wheels, and practically everything you see around and in front of you that's not food. Of course, some mines do extract potash, which is used to grow the food we eat. We use diesel-powered equipment to create the tunnels and extract the ore. It's become clear over the past couple of decades that breathing diesel fumes is bad for human health. Cancer clusters and clusters of other illnesses are found around the world near congested roadways and ports, where a lot of diesel particulate matter is produced. We all close our windows when driving through city tunnels to keep out the fumes. In a mine, it's not that easy. We're often working without the benefit of enclosed cabins. The exposure of our miners to DPM is excessive compared to the normal population, and this needs to be fixed. That is the primary health piece of the puzzle that we are working on. To help you understand where the direct economic benefit is, mines are regulated to pump a certain volume of air through the mine every second based on the total combined kilowatts of diesel power being used in the mine. If you think about blowing air through a straw, you start blowing, a little bit comes out, blow a bit harder, more comes out. But you get to a point where your eyes are popping out of your head and your cheeks are stretched and you just can't blow any more air through the straw. That happens in underground mines and we call it ventilation constraint. For every extra cubic metre of air we try to push through, our power costs skyrocket. Most mines in Australia operate under ventilation constrained conditions. And at this condition, if you wanted to add one extra diesel ute into the mine, it'll cost you an extra 100 to 150 grand per year in electricity costs to move the extra air required. And the same is true in reverse. If we replace one diesel ute with an electric vehicle, that's the electricity costs we can save. There are underground mines in Australia that have 250 utes running around their tunnels. The average is about 25 per mine. So if you only get the benefit of reducing air volume, the average mine can save around $3 million a year on electricity by swapping out their diesel-light vehicles with electric ones. But it doesn't end there. Many of our mines are deep and quite humid due to water ingress. And they can be operating at the working face with wet bulb temperatures above 30 degrees. When you add to that the requirement to wear overalls, gumboots and a hard hat, cooling the human body can become very difficult. In these mines, we have gigantic air conditioning units which cool the air going into the mine to try to keep us below that magical 32 degrees wet bulb limit where people start falling over. Electric vehicles produce 90% less heat than diesel equivalent during operation. Turning these air conditioners off can have the same or higher cost benefits again, and they don't add to the humidity of the environment. So all of us tech heads have been using the excuse of reduced maintenance and operating costs for our economic reasons to change to EV. I hope you can see from my little Mining 101 short course that the benefits in mining far exceed just maintenance and operating costs. When Tesla launched the Roadster, it was obvious to me that if this can work on road, then it can work far better underground. I spent years watching and waiting for the OEMs to do something about it, searching to try to find someone who was, so that we could help them get traction in Australia. But nothing good was forthcoming. You see, the business model for OEMs of mining equipment is to sell the piece of equipment at a competitive price and then reap the benefits of a lucrative parts and servicing tail. Electric vehicles simply don't have the servicing or parts requirement that diesel vehicles do. So implementing this change was always going to be challenging for the incumbent businesses. Mining companies, on the other hand, who receive the benefits of this new EV technology underground, don't invest in product innovation. Their R&D budgets are around drilling to find new ore bodies. And they've got a reasonable expectation that the OEMs will do the development work for them. This is why there is a commercial opportunity for small businesses like Safe Escape to push into a market that traditionally would have seen us stomped on quickly. Light vehicles in Australia are mostly Toyota Land Cruisers, with some purpose-built tank-like machines. The Land Cruisers are used because they're the only on-road vehicle that lasts any reasonable time in this environment. And they cost around 100 grand to purchase and fit out for underground. The tanks are up around the 250 to 300 grand mark. The average underground light vehicle will last 3 years, and in many mines, they'll consume approximately 200 grand worth of parts during that time. I understand this sounds ludicrous to the non-miners on the call, but it's true. Underground mines are a hideous environment for a road-going vehicle. The air is dirty and wet. The road you're travelling on is unsealed and at a 1 in 7 gradient. You're in four-wheel drive low range all the time, and because no one can see you and you have an important job to do, you'll drive the vehicle with your foot flat to the floor the whole time. On top of that, most mines are wet with hypersaline water. Often the water is also acidic. I've seen water that could eat through a 3 mil thick sheet of steel in 24 hours. So it got to a point in 2018 when we decided we would make an electric light vehicle for mining because we couldn't see anyone else doing it. At that point, we didn't even consider using any of the vehicles currently used underground in Australia because we knew that the EV technology we were going to put into the vehicle would outlast 3 of the donor bodies, and this would be inefficient. So we searched the globe to find a vehicle that would last. We found it in the Agrale Marua. This vehicle is a purpose-built military vehicle. It's incredibly heavy duty, everything's over-engineered, its body is completely galvanised, and the chassis is sealed. Unlike other road vehicles, where the holes in the chassis allow them to rust from the inside out. It's made in Brazil by Agrale, who make trucks, buses, and tractors. It's built on a traditional production line, but it's built to order, which was very important to us. It means we can make changes to the design of the vehicle so that it has mounting points to suit our batteries, motor, etc., and we don't have to remove components when we get the body into Australia. So to be clear, we're not retrofitting. It's a ground-up build of an EV that uses the bones of an existing diesel platform. When we build the Bortanas, they'll have our VIN number stamped on them, and they will be available for road registration. Initially, we'll have single cab and dual cab options, and it's likely we'll also progress to a minibus option as well. We've built our prototype and tested it over the past 18 months, including about 6 months on mine sites around the country. It's been received extremely well, and we'll begin delivery of our beta phase fleet in the first quarter of 21. To understand the decisions we've made, you need to have some understanding of why we do what we do and the market that we're working in. I hope you can appreciate the reasons for choosing such a ridiculously tough platform, and yes, it is heavy. The tare weight of the Bortana is about 3.5 tonne, but considering it has a GBM of 5.7 tonne, it still has a useful payload. When we looked at batteries, we wanted lowest total life cycle cost, which we saw as being made up of very high quality NMC pouch cells, extremely robust, extremely safe, and maintainable. So you're probably thinking we're asking too much. There isn't anything on the market that meets all of those criteria, and you would have been right. Our partners at 3Me Technology in Newcastle have designed a battery that meets all of the input requirements, and only time will tell whether we achieve that overarching goal of lowest life cycle cost. To be clear, our batteries are not cheap, but they are good value. Charging gets interesting for our market. In Australian underground mines, we reticulate 1000 volt AC power. There are power points distributed throughout the mine. There's one on pretty much any wall where you might consider to park the car, and they can supply anything up to 200 kilowatts. Unfortunately, when we started, there was no such thing as an onboard charger that receives 1000 volt AC, because in Europe and North America, 1000 volt is quite rare. There are no 415 volts outlets in underground mines, nor are there yet any high-speed off-board chargers. So to get started, we needed 1000 volt on board. 3ME again led this project and chose a particularly capable manufacturer in Europe to build us a charger. When we are charging the vehicle underground, near to where the driver is out working, we don't want them to have to walk back to the vehicle to check state of charge. We needed a system on the vehicle that would report state of charge at a reasonable distance. An RGB strip was programmed to show the state of charge in increments of 33%, beginning with red, then orange, and yellow. Finally, when fully charged, turns green, which is great if you're not colorblind, but for people like me, we added an extra feature for when it's fully charged. I don't know if you can hear the music, but there's a bit of a pop culture reference going on back there. If you're as old as me, you'd know that that's Knight Rider. If you're younger than me, then maybe you should check it out. Back to the importance of 1000 volt charging. You see, some mines in Australia are up to 2 kilometres deep. If we started shift on the surface and drove to the bottom of the mine, we would have to start with less than 70% state of charge because the amount of regen you get from going this deep. There would be an extreme element of range anxiety if we couldn't charge underground. Sure, we could have asked our customers to install off-board chargers at strategic locations throughout the mine, but the cost of this is not just the capital, but also the time wasted waiting to charge a vehicle at a location where you can't be doing work. By using the existing infrastructure, workers don't have to stop to charge their vehicle. Instead, they just charge when they're stopped for work reasons. The Australian mining industry is poised for a period of significant advancement in terms of productivity and safety. The whole team at Safescope is proud to be contributing to this change.